We continue learning workbook page 174 with a second ALEKS problem regarding graphing exponential functions. We now turn our attention to g of x. Graph the function g of x equals 3/2 to the x power. Use x equals -2, -1, 0, 1, and 2 in your table of x values. And don't forget to draw the asymptote. Okay, let's begin. So we know that g of x is the same thing as y. So our equation is y equals 3/2 to the x power. Let's plug in each one of these values of x one at a time. If x equals -2, then y equals 3/2 raised to the -2 power. This is where it's very important to remember your intermediate algebra rules. If you have a over b raised to the n power, that can be rewritten by flipping over the fraction and changing the sign of the exponent. So a over b to the -n is the same as b over a to the positive n. We can use that here. So let's make this 2 over 3 raised to the positive 2 power, which is 2/3 times 2/3. Multiply the fractions. 2 times 2, 4. 3 times 3, 9. So the value we get is 4/9. Okay, let's try another one. If x equals -1, then y equals 3/2 to the -1 power. Flip it, change it. So I get 2/3 to the first power, which of course is simply 2/3. All right, if x equals 0, you probably already know the answer to this one, then y is equal to 3/2 to the 0 power. Any non-zero number raised to the 0 power is 1. All right, running out of space here. Let's do some erasing. All right, next, if x is 1. If x equals 1, then y equals 3/2 to the first power, which is 3/2. And finally, if x equals 2, then y equals 3/2 squared, which is 3/2 times another 3/2. Multiply the fractions. 3 times 3, 9. 2 times 2, 4. So we get 9/4. Okay, so now that we have all of the points in our table, we're pretty much ready to create our graph. I would like to get some decimal approximations for some of these fractions because it'll just make it a little bit easier for us to graph. 9 divided by 4 is equal to 2.25. 3 divided by 2 is 1.5. 1, of course, is just 1. 2/3 is 0.6 repeating. And 4/9, I'm pretty sure, is 0.4 repeating. But I'll verify that. 4 divided by 9, 0.444444444. Okay, great. All right, so now that we've got some decimal values, it should be a little bit easier to graph our y values. These are all positive, so once again, we only need quadrants 1 and 2. And the y values don't go up very high. They only go up just a little bit past 2. So let's do this. Let's say that's 3, and that's 2, and that's 1. Our x's, let's make a square out of this. So our x's are 1 and 2 and -1 and -2. And that should allow us to plot our points. So let's see if we can find the y values on the axis first. So 2.25, that's approximately here. 1.5, that's approximately here. 1 is here. 0.6 repeating is approximately here. And 0.4 repeating is approximately here. All right, so with that in mind, now we should be able to plot all of our points. Let's begin. So 2 9/4. So 2 9/4 is about here. 1 3/2 would be approximately here. I could use the decimal values when I say these. 2, 2.25 would be about here. 1, 1.5 would be here. 0, 1 would be here. -1, 0.6 repeating would be approximately here. and negative 2, comma 0.4 repeating would be approximately here. Now connect your dots together, and we see the familiar shape of the exponential function. And just like all exponential functions we've looked at previously, we have the asymptote sitting right on top of the x-axis. There you go. If you don't have the luxury of writing your asymptote in a different color, and you're worried about the fact that it won't be able to be seen, just make it thicker. Don't move it up, don't move it down, just make it thicker. That way you can see the asymptote and know where it is located, as well as the axis that it is sitting upon. All right, great, there we go. So we have now completed both ALEKS problems on the learning objective graphing exponential functions.